This is Giovanni Cornejo, and this is Screencast for Project 2. The header file contains all function prototypes outlined in the project document in these private variables: the size of a word in bytes, the function allocation algorithm currently being used, the total byte size of the block, a pointer to the top of the block, and 2 arrays for keeping track of holes and allocated block offsets and sizes. There are also 3 helper functions I will go over later to aid in managing these arrays. The best fit function works by initializing a large number as the current size and the offset to -1. It then loops through the list and checks if the current hole has enough space for allocation and is smaller than the current track size. If so, the current hole offset and size are stored. The worst fit function works similarly, except the current size is initialized to a small number, and sizes greater than the current track size will be stored. The constructor initializes the word size and allocator to the corresponding values passed in. All the private variables are initialized to 0 or null pointer. The destructor resets the heap to the original position via the break system call found in the unstd.h include file. During initialization, the first allocation of memory is done for the whole list, so resetting the heap break address to the beginning of this array will accomplish this. During initialization, the previous memory block is cleaned up if applicable by calling the shutdown function. The current whole list and block list are also deallocated via a break statement. The whole list and block list are reallocated with the size based on the passed-in size in words. The sbreak system call will allocate memory of this size and return a pointer to the start address of the allocation. The whole list will start with one hole that is the size of the entire memory block, while the block list has a size of 0. Lastly, the memory block is allocated onto the heap with a size equal to the byte limit. The shutdown function resets the memory block to its original position by changing the break address of the heap to the start of the head. These 3 helper functions are used during the allocate and free function calls to update the block list and whole list accordingly. Add block will loop through the offsets that are greater than the passed-in offset. These are pushed back to make room for the new block. Remove block uses binary search to recursively find the index at which a block is to be removed. From this index, all values are pushed up and effectively overwrites/remove the block. Allocation works by first aligning the passed-in byte size to a multiple of the word size. The current allocation algorithm function is called to retrieve the word offset of a hole that can fit the passed-in size, if available. The hole size of the acquired offset is then retrieved. The current block is then removed from the whole list and added to the block list with the passed-in size. The previous hole size and offset are recalculated if a hole still exists after allocation. Lastly, a pointer is returned to the starting position of said allocation. The function first converts the passed-in address to a word offset. The block size of the word offset is then acquired. The previous and next item in the whole list and their word offsets are checked to see if coalescence is needed. A previous hole may be removed, and the whole offset is shifted back, and the current hole size is increased. The next hole may also be removed, and the current hole size also increases. Lastly, the block is removed from the block list, and the new hole is added to the whole list. Set allocator changes the currently used allocation algorithm to the one passed in. Dump memory map function uses standard POSIX calls to write the whole list to a file as text. First, the whole list is converted from an array into a string. Via the fcntl.h and unistd.h include files, the passed-in file name is opened and rewritten with all permissions set to true for all users. Then the string is written to the file as a C string with the buffer size as the string size. The getList function returns a copy of the memory manager's whole list to the caller. For the getBitmap function, the first part is to convert the whole list into an array of bits. Looping through the size of the bit array, when the current bit value equals the current hole's offset, zeros are added equal to the size of the hole. Otherwise, ones are added to indicate that the word is currently allocated. The second part is to create the bitmap. The size of the bitmap is stored at the beginning in little endian. Looping through the number of bytes, each group of 8 bits from the bit array are added together in reverse and stored in the bitmap. The bit array is deleted, and the bitmap is returned to the caller. These 3 getters return the word size, the memory address at the beginning of the memory block, and the byte limit of the current memory block. For the demo, I just followed the steps outlined in the PDF to build the provided test program and linked it against the library. So if I go ahead and run this, you'll see that it passes all the tests, which indicates that the memory manager is working correctly. To end things off, Valgrind can be used as a way to test for memory leaks by running it against our compiled program. And after this, it says all heap blocks are freed and that no leaks are possible.